Sending log files to Elasticsearch is a common use case that's easily managed within the StreamSets data collector. Our goal for this tutorial is to bring in log files from a directory, send them to Elastic, and view the resulting data in Kibana. A downloadable version of this tutorial is hosted on GitHub. Feel free to clone that repository to access sample data, the data collector pipeline, and a Kibana dashboard. Before we get started, here's how we are set up. We'll read log-rotated gzip files from a local file system directory. These files are combined log-formatted Apache access log files. The fields we are interested in are host, that's the IP address of the client, datetime, that's when the request was made, request, the HTTP verb sent to the server, the URL requested, and the HTTP version, status code, that's the return code generated by the server, bytes, how much data was returned from the server, referrer, that's where this request came from, and the user agent. Our data collector pipeline will read these log files, make a few simple transformations like remove unnecessary fields, convert strings to integers, geolocate the IP address, and finally store them into Elastic. We'll need to set up an index with the right mapping within Elastic, and here's the command to do that. Here we're telling Elastic that we need a datetime field to store the time the request was made, and the latitude, longitude, and the city the IP address resolves to. Check out Elastic documentation to learn more about this setup. And again, the GitHub repository has this command in text form, so you copy and paste that into your own environment. Let's get started. Here's a sample ingest pipeline. We'll start with the directory origin. In its configuration, you'll want to select log as the data format. You'll need the absolute path to the directory containing the log files. Our file is gzipped, so enter the wildcard star.gz in the file name pattern, and select compressed file from the file compression dropdown. The data collector supports a large number of compressed file formats, so if your files happen to be .zip or something else, those would work too. Just adjust the file name pattern to match. Also, if you're trying to read uncompressed log files, you can leave this field as is. Next, go to the post-processing tab and set post-file processing to none. In a production environment, you might want to delete your source log files after they're copied over to Elastic. To do this, set this option to delete. For now, we'll just set it to none as we don't want to delete those files. And in the log tab, set the log format to combined log format. The expression evaluator lets us use Java expression language, EL, to alter fields. In this example, we'll create a field called geo and set it to an empty map data structure. We're going to populate this field with lat-long values further down the pipeline. Now let's look at the field converter. By default, the data collector will read the fields of this log file as string values. But we know the data types of some of them, and they'll be useful for queries if converted now before they end up in Elastic. Here we set up the bytes field as a long, the response code as an integer, and the timestamp field as type datetime. That's read using a format specifier shown here. The format used is a standard Java format specifier, so you can alter that easily to suit your needs. Next, we'll use the GeoIP stage to look up IP addresses and find the latitude, longitude, and hence the city the request came in from. We're using the free Max GeoIP database for this lookup. Check the GitHub tutorial to see how to download that database. The setup here is that we use the client IP address, match it in the database, and find the city name, latitude, and longitude it corresponds to. And finally, we'll use the Elasticsearch destination to send data into Elastic. All you do here is select the target version of Elastic and specify the cluster name and address. The easiest way to get started is to hit the preview button. This switches the IDE into a debug mode that reads a small subset of the data and lets you introspect the data as it flows through the pipeline. You can specify whether or not you want this preview data put into the target destination. In this example, we won't write it to the target. When you're in preview mode, you can click through each stage and see how the data looks coming into it and after it has been transformed. If you've made any mistakes in your logic, you can easily use this information to make corrections on the fly. Here's a neat example of seeing data in preview mode. Notice the error notification on the GeoIP stage? Click on it and you'll see the IP address on one record didn't match anything in the GeoIP database. You could choose to handle this error as you see fit. In our case, we'll just ignore it since we're not interested in sending this data to Elastic. Now let's fire up the pipeline. Hit run and the IDE switches into an execution mode and starts sending data through. At this point, you could use the metrics monitor widgets below to get a sense for how the system is doing. For example, the record count shows you how many records were read, how many made it through, and how many errored out. Here's another interesting widget. The stage batch processing timer shows how much time each stage in the pipeline takes to process the data. You can use this to pinpoint performance issues in your pipeline. You can also click through each stage and see stage-specific metrics. Finally, let's look at how the data looks on the other side. Here's a sample Kibana dashboard that shows some summary statistics of logged data coming into Elastic. Pipelines like these are typically left running continuously. Every time a log file gets added to the origin, the data collector automatically picks it up and sends it downstream. And there you have it, a simple way to read, transform, and deliver log files into ElasticSearch and Kibana to enable a real-time analytics dashboard.